Greetings. I've cleaned the roller jewel hole in my grandfather's pocket watch. My next step is determining the desired diameter of the replacement jewel. I'm going to share what I've learned about two ways of measuring small distances. In my case, I'm measuring the pallet fork gap into which the roller jewel must fit. This video is part one. It's about using the microscope to do it. In part two, I'll talk about using a physical gauge. The modern way is to use a microscope eyepiece that contains a calibrated reticle. You align the scale with an object you see in the eyepiece. Then you count the number of reticle hash marks it spans and convert that to a measurement, usually in millimeters. The old school way is to use a roller jewel gauge. You stick a gauge's tip into the gap. If it won't fit, you try smaller ones until it does. I'll talk about gauges in part two. To use a microscope with a calibrated eyepiece reticle, you have to buy three things. One, a microscope. Duh. I bought a decent one for about $550. It should carry me for a few years. Two, an eyepiece with a reticle. This is the one I bought. It will replace one of your existing eyepieces, so it must have the same outer diameter and magnification as what it replaces. It has a measured scale etched into one of its lenses, which is always visible to you. In mine, it's aligned with 100 hash marks in groups of 10. The typical cost for a decent one is $20 to $50. Could you buy cheaper? Sure, but don't do that. 3, a reticle calibration slide. Its technical name is a stage micrometer calibration slide. This is the one I bought. It has one or more targets with known sizes. Good ones have multiple targets that are useful in different calibration situations. Mine has these. The typical cost for a good one, $20 and up. Could you buy cheaper? Sure, but don't do that. So how do you use this hardware? The first step, which you'll do only once, is to calibrate the reticle, because the etched scale will measure a different span at different magnification levels. As a refresher, a microscope's total magnification is the eyepiece magnification value multiplied by the objective magnification value. My eyepieces are 10x. My scope's objective ranges from 0.7x to 4.5x. So the scope zoom knob is marked 0.7 through 4.5. So I multiply the two numbers. So the total magnification range of my setup is 7x to 45x magnification. To calibrate it, you put the calibration slide under your objective lens at the same height as your movements will be. You can start with any magnification level. I started at 0.7 on the knob, which means a total magnification for me of 7x. Now you look through the eyepiece and bring the slide into focus. This is my actual calibration slide at 7x magnification. That line is 10 millimeters long. Each number is 1 millimeter apart, and the hash marks are 0.01 millimeters apart. Now I can't show you what I actually see because the reticle isn't visible in my camera port on the microscope. But here's a reproduction. The thick line is a reproduction of the reticle, although in my eyepiece it's actually always centered in my field of view. Ideally, you should align the 0 hashes so they overlap. You can also align the 0 hash of one with any hash mark on the other and do a little math in your head. As you can see, the entire calibration line, which has 100 hash marks, covers the same distance as about 68 reticle hashes. Now we know the calibration slide target is 10 millimeters. So we now know that at 7x magnification, the reticle hash marks are 0.1471 millimeters apart. Now I align the zoom dial to the number 1, which represents 10x magnification in my setup. And I repeat the exercise. Here's what I see. And here's the math for calibrating the reticle at 10x magnification. It was a little over halfway between the 98 and 99 hash marks, so I just judged it to be 98.6 hashes long. Now, notice something. At 10x magnification, the scales should precisely overlap, but they don't. Why not? The first reason is that there's some play in the magnification dial, and in its connection to the lens element, the internal lens element being moved. This is a $550 microscope, not a $55,000 microscope. The second reason is that this microscope was never calibrated so that the 1 on the zoom dial is exactly 1 times objective magnification. It could be 0.97, it could be 0.99, it could be 1.03, anywhere in there. In fact, the lowest objective zoom level on this scope is 0.7, and yet the knob on this scope goes a little below 0.7. The markings of 0.7, 1, 2, 3, 4, etc. are approximations of the zoom level when the knob is set to that mark. Now the third reason is that there's also a little parallax between the ends of the magnification scale, meaning I can shift its position relative to the reticle a little if I move my head and my eye left or right within my field of view. Does any of this matter? No, as long as you're aware of the eyepiece parallax. I did this for other magnification numbers, and here's what I came up with for my reticle calibration. Now, the computed column is what the calibrated values should be if the microscope and its mechanics and its zoom dial were perfectly calibrated. I'll never use that column, it's just an interesting thing to compare. The important column is the last one. When I want to measure a distance on something under my microscope, I'll bring it into focus, dial in a magnification level that's in this chart, measure its spanned distance, and multiply the number of reticle hashes by the number in the right column. Let's do a simple example. On the pocket watch, the words American Waltham Watch Company are etched on a bridge. Let's say I want to know how long the letters CAN are at the end of the word American. Yeah, I know, this is just an example. So here are the letters at 20x magnification. I set the zoom dial to 2, which remember is just an approximation. So saying this is 20x total magnification is also an approximation. So these 3 letters are about 85 reticle hash marks long at 20x. So they're about 4.17 millimeters in length. Now you can measure whatever you want as long as you can see it in your scope. In my case, I want to measure the pallet fork gap for the now missing roller jewel. Among other considerations, the jewel needs to fit into this gap. I've marked the gap width with an X in this photo. I measured it at 45x magnification. The gap was about 25 reticle hash marks wide, which computes to 0.56 millimeters. The roller jewel should be 2/100ths of a millimeter narrower than this gap. So according to my reticle measurements, I need a jewel that's 0.54 millimeters wide. To summarize using an eyepiece reticle before signing off on this video, using a reticle is general purpose. If you can see it, you can measure it, and that's an advantage. It requires an initial calibration. It requires that you keep your hash distance table handy. I taped mine to the base of my microscope. It requires that you do a little math, nothing challenging, but you've got to do it. Assuming that you already have a microscope for general use, you'll need to spend between $40 and $100 on the eyepiece reticle and a calibration slide. It's a little error prone because you better make sure you count the hashes correctly and do the math correctly. I'll admit, in preparing this video, I did the math wrong a couple of times. In part 2, I'll talk about using a physical gauge, and then I'll compare the 2 techniques. That's all I have for you today. Remember that age is just a number. Till next time, take care.